In this video, I'm going to work through the exact same scenario that we saw in the last video, but it'll be a little bit more mathy. And the reason why I'm going to make it a little bit more mathy is so that you see it's the same ideas. It's going to have a little bit more cryptic notation, but it allows us to generalize the ideas that we saw in the last video. So let's just assume, instead of saying that the marginal propensity to consume in our little island is 0.6, let's just call it a general, let's just say our marginal propensity to consume is C. And what we want to do is we want to figure out, given some initial change in expenditure, and this guy's change in expenditure will be this guy's change in income, how is that going to, and as that cycles round and round due to the multiplier effect, what is going to be the total change in our GDP? So this is what we care about. We care about our total change in GDP. And the GDP, Y, could be viewed as expenditure, or it could be viewed as income, depending on how you think about things. So let's say this guy, instead of saying that he's going to spend all of a sudden $1,000, let's just call his incremental change in expenditure, let's just call that delta Y naught. And delta just means change in, and Y, we could view this as aggregate expenditure. And I'm putting this little 0 here, so this is our first iteration. This is the first time that we're doing this one of these deltas. And then as we keep doing them, we're going to have Y1, Y2, Y3, and so on and so forth. So if we think about the total change in GDP, you're definitely going to have this. In the last example, this was $1,000. This guy's $1,000 expenditures. This guy's $1,000 income. So then you have delta Y naught. But then we saw that this guy, his marginal propensity to consume is C. So he's going to spend, of the income he gets, he's going to spend C times that. So he's now going to do delta Y1. This is the next kind of incremental bump in our GDP we're seeing. And that's going to be equal to C times what he just got. And so now after doing the 0th iteration and the first iteration, our total change is going to be C, actually let me write it this way, times delta Y1. And delta Y1, this is just the same thing as C times delta Y naught. So it's kind of fancy notation, but it's saying something fairly basic, the exact same thing that we said in the last video. Now this guy, all of a sudden, above and beyond what he spent in that 0th iteration, he's now getting delta Y1. He has a marginal propensity to consume. We're just assuming of C. So now he's going to spend C times that. So he's now going to make an expenditure of, I'll do this, well, just in the same color. He's now going to do delta Y2, which is equal to C times delta Y1. And so now we have delta Y2, this new incremental bump. And they're getting smaller and smaller and smaller, but we can go an infinite number of times. And just to remember what this is, delta Y2 is the same thing as C times delta Y1. Delta Y1 is the same thing as C times delta Y naught. And so this thing right over here is the same. This whole thing can be written as C squared times delta Y naught. This right over here is C times delta Y naught. C times delta Y naught. And this, of course, is equal to plus, this is just delta Y naught. And we can just keep going. If this guy will then get this amount, and he'll spend C times that to the farmer. And so if we had a Y3, it would just amount to C times this, which is be C to the third times delta Y naught. And we could keep going on and on and on an infinite number of times. But each of these terms are going to get smaller and smaller because we're going to assume, in order for this to actually work, we're going to assume that C is between 0 and 1. C is less than 1. Obviously, when someone gets new income, and thinking of the simple case, someone's not going to be able to spend more. Their marginal propensity to consume, we assume they can't spend more than they just got. And in general, they're not going to spend the whole thing, so we're going to assume that it is less than 1. And so this is exactly the same idea that we did in the last one, but now it is general. And we can simplify this a little bit mathematically. So this is all equal to our delta Y, our total bump in GDP due to that initial spark. And if we factor that initial spark out, we have the delta Y naught. Actually, let me do that in a different color just so that the math becomes clear. We have the delta Y naught, delta Y naught, delta Y naught, delta Y naught. When I say not, I'm talking about that 0 subscript. If we factor that out, we get our total bump in GDP. Our total bump in, whether you want to view it as output, expenditure, or income, is equal to, we're going to factor that out, the delta Y naught times, and then we're just left with we are just left, you factor the change in y naught here, you get 1. And then over here, plus c squared plus c to the third, and you go on and on and on. And in the last video, I told you that this right over here is going to simplify to 1 over 1 minus c. So this is equal to, this part over here is equal to 1 over 1 minus c. Now, you might have not been satisfied, and since this is a more mathy video, it's a good place to actually show you that it would sum up to 1 over 1 minus c. So not to introduce too many variables, but let's just call this thing x. So let's just say that x is equal to this whole thing right over here. It's equal to 1 plus c squared plus c to the third, so on and so forth. Now let's imagine what we would get if we multiply x times c. So what happens if I multiply, I'll do this in a different color, what happens if I multiply c times x? Well then, each of these terms I can multiply by c. So 1 times c is c times c is c squared times c is c to the third, the c to the third times c is c to the fourth, so on and so forth. Now, what happens if I subtract this from that? If I subtract the left-hand sides, I get x minus cx. So I get x minus cx on the left-hand side. We'll do that in that pink color. Minus, where did it go? Actually, I think I changed the color on my, so I'll just write x minus cx, and that's going to be equal to, if you subtract this stuff from that stuff over there, this, you'll have a c minus c, they'll cancel out. Let me do this in yellow. C squared minus c squared, that'll cancel out. C to the third minus c to the third, that'll cancel out. So every term other than 1 is going to cancel out. Everything is going to cancel out. You're just going to be left with a 1 here, which is a pretty neat trick in my mind. And then we can factor out the x right over here. So you get x times 1 minus c is equal to 1. And then you divide both sides by 1 minus c. You get x is equal to 1 over 1 minus c. And x was exactly this thing right over here. So this thing is equal to 1 over 1 minus c. So this right here, we just showed you exactly what we were we told you in the last video. That the total bump in GDP, this right over here, you can view this as a total bump in GDP, is going to be equal to that initial bump in GDP, which we called delta y naught. That was that initial spending that that farmer did for the builder's initial income. That the total bump is going to be equal to that initial bump times this expression, which we view as the multiplier. And this is the multiplier right here is a function of the marginal propensity to consume. So this right over here, let me label it all. Actually, let me just rewrite it. So the total bump in our aggregate expenditure or output or income is going to be equal to the initial bump times the multiplier, which ends up being a function of our marginal propensity to consume. So this right over here is our multiplier, and this right over here is, you could view that as our initial bump. And just to make sure that it works out from what we saw in the last video, our marginal propensity to consume was 0.6. So C was 0.6, and our initial bump, our initial expenditure was equal to 1,000. And if you put 0.6 in here, you will get 2.5, and so you get the exact same multiplier, and you get the exact same total bump in GDP as we got in the last video. At least now we have a little general, and you're hopefully a little bit more comfortable with some of this notation that I'm using. And unfortunately, you'll see different notation in almost every economics textbook. I just want to make sure that this makes reasonable sense to you.